Let's take a quick look through the polarity and intermolecular forces gizmo on Explore Learning. We'll launch a gizmo by pressing on this button, and we wait for the gizmo to load. There are three key tabs here. The first one is bond polarity, the second one is molecular polarity, and the third one is intermolecular forces. We're going to start from the beginning, bond polarity. We've tried to use the show valence electron checkbox, and you can drag in and drop different types of metals. We'll start with ionic bonds. We'll do a sodium chloride bond, and we see that sodium has the 1 valence electron and chlorine has the 7 valence electron. They're purplely colored right now. That means they're neutrally charged. Blue here is positive charge, and red here is negative charge. If we click on play, we see these two atoms come closer together to form a bond, and now this electron from sodium is now completely stolen, occupied by chlorine. And we see that sodium here is blue, so it's positive, and chlorine here is red, so it's negative. You can click on this camera screenshot and put it into your assignment. Click on this X to come out of the screen. You can then reset to original values, and then you can also drag the atoms back into the boxes and select other atoms. For example, we can do nitrogen, and we can do a hydrogen, and they will show us the molecule NH3, ammonia. We can repeat the process, click on play, and we know what it's at. In ammonia, nitrogen is slightly red, so it's slightly negative, and hydrogens are slightly blue, so it's slightly positive. We'll reset and drag these atoms out of the box. So that's bond polarity. To look at molecular polarity, we click on that tab, and we can drag in a polar molecule, in this case, sodium nitrogen trichloride. We'll turn on the electric field, and we'll see that the slightly negative end of the molecule nitrogen is pointed towards the positive end of the electric field, which makes sense because a positive end of a molecule will point towards the negative end, and then the chlorine, which is the slightly negative end, will point towards the positive end of this electric field. If we click on reverse field, we'll see that the molecule will flip. So that's molecular polarity. You can drag and drop different molecules in there and see how they react. These the bonds here are polar, and as well the molecule is polar, but then you can see the orientation of the molecules. The last thing we can look at is intermolecular forces. We can drag in some polar molecules, so ammonia, and we'll drag in a couple more ammonia. If we play, we'll see the molecules move randomly, but for a split second, they're frozen in time, and you can click on the pause button to pause it. And we'll see here, there is a temporary bond between the negative end of ammonia, nitrogen, with the positive end of another ammonia molecule, hydrogen, and this here is our hydrogen bond. You can then reset the molecule, you can drag the molecule, you can try other molecules, so you can do nonpolar molecules, carbon tetrachloride, do the same thing, and you can wait as long as you want, but there will not be any hydrogen bonds. However, there will be sometimes some very weak London dispersion forces. So this is due to the movement of the electrons within a molecule temporarily. It will generate a slight negative on one chlorine and a slight positive on another chlorine, and you'll get a very, very weak London dispersion bond between these two molecules. Again, you can reset and try different molecules. So those are the three important parts of this gizmo. If you have any questions, please drop in a comment.